So with the permission of the all, we can start the program. If Dr. Meghali, if you think it is okay.
Should I start?
Yeah, better. What do you think, sir? Should we start or should we wait for some more time?
No, we can go ahead. Why waste time? We can go ahead.
Yeah.
Those who are interested, they will join.
Yeah, that's right. Because it is being telecasted live also, so we need to maintain the time.
Sure.
And so, yeah, you can do it.
Okay, sir.
And yeah, you can start the program.
Okay. A very good afternoon to all the dignitaries and participants joining us from India, and a very good morning to those joining us from other parts of the world. I, Dr. Meghali Borua, welcome you all to this international webinar on permafrost research opportunities and scope in India, which is jointly organized by the Department of Geology, Northeastern Hill University, Shillong, in association with Permafrost Young Researchers Network coordinators. So to start the session, I would like to enlighten our audience about Permafrost Young Researchers Network. It is an international organization established under the patronage of the International Permafrost Association, fostering innovative collaboration, seeking to recruit, retain, and promote future generations of permafrost researchers. And I am very much sure that the talks by the eminent personality in today's webinar will be of immense help in understanding the opportunities and scope of permafrost research in India. So without spending much time, now I will play the Saraswati Vandana to initiate the program, as Saraswati is the goddess of knowledge, music, art, speech, wisdom, and learning in Hindu mythology. So now moving ahead, it is my okay, due to some technical issues. Okay, moving ahead, it is my absolute pleasure to call upon our head Department of Geology, Northeastern Hill University, Shillong, Professor Devesh Walia, for the welcome speech. Sir has rich experience of more than 30 years in the field of geological sciences and working especially in structure and tectonics of Northeast India region. Sir is an expert committee member of Landslide Hazard Mitigation, DST New Delhi, and also an expert member of district level Environmental Impact Assessment Authority, East Khasi Hills District, Meghalaya, India. He has published his research findings in various peer-reviewed journals. Now I request Professor Devesh Walia for delivering the welcome speech. Over to you, sir.
Yeah. Thank you, Meghali. I would like to welcome you all on this very, very important program. As such, we all know that the permafrost studies, they are at the backbench, especially in India. Although considering the importance of it, especially in the northern hemisphere, it has got a great role to play. So I, on behalf of Northeastern Hill University, would like to welcome you all, especially the panelists, Professor A.D. Ahluwalia ji, Dr. Rasik Ravindra ji, Dr. Carla Tapia, and others, Izaz Ahmed ji and Dr. Dr. Adam Kirkwood ji, for this very, very important program, which may bring in or which may link some younger people, younger researcher in this network. Such studies of global scale can only be carried out until unless there is a strong network of the people and they are able to collaborate, cooperate, to bring forward, to help understand the difficult or the technical issues related to permafrost and its the impact of climate, especially on it. We all know that Shillong occupies very, very important place, especially in the geology of Northeast India. Why? Because Shillong Plateau is considered to be one entity and it is considered to be the broken part of the Indian plate. And with time, it has moved towards Europe, Eurasian plate, and has given rise to mighty Himalayas like mighty Himalayas and other major features in this zone. So, as such, this place has got very important tectonic features which can be studied, and considering all the important aspects, the Department of Geology has been established at Shillong. Shillong being seat of various geological resources and the various metallogenic epochs and provinces, due to which almost all ages of rocks are present, and especially the rocks with the various mineral resources, they are there. At the same time, the Shillong provides a field which has got almost all types of the folding, the faulting, or whatever structures, important structures, they are present in this region. Considering the importance of the region, our university, although we had our campuses at Nagaland, at Mizoram, and the Department of Geology has been there at Nagaland as well as at Aizawl, but now we have started from 2021 only, the new department with a new focus, with a new team, and with new energies to take forward the cause of studying geosciences and to unravel some of the mysteries, and also to help take out the various mineral and energy resources from this remote region and still to be studied region in India. As such, the Department of Geology is located in the main campus, permanent campus of Shillong, and at Northeastern Hill University, we have got very good Department of Chemistry, Department of Physics, and Department of Botany, Zoology, or Biochemistry, Biotechnology. Along with this, we have got one of the best resources in the form of library, as well as sophisticated analytical instrumentation facility is there, which may help the students from the not only from the northeastern region but from the India to take up the studies and bring their whatever target to a reasonably good place, so that they are able to contribute for the national and the international mindset and development by providing various kind of knowledge or by various kind of information. So without going too much deep into the topic, I would like to welcome you all again. Those who have taken out time, we know that this program is streamed live on YouTube. So once it is streamed, so this program is going to be there forever, and the students community, the researcher community, or anyone who is interested in knowing or in taking forward the cost of the taking forward the cause of permafrost and such studies can access these YouTube video and can learn as per his or her convenience. So I would like to once again welcome the Permafrost Research Organization Young Researchers Network (PYRN) to have given us chance to organize a program of this magnitude. We know that on Saturdays especially, we have kept the timing in the evening because so that to match the time of various experts, they are able to take out time, because as was pointed out that at some places it is morning, whereas at Shillong it is evening. So we have to reach, we have to divulge, we have to bring all the places at one forum so that we are able to express, we are able to understand, we are able to take forward the cause of studying the permafrost research. And as such research is there, it brings in lot of opportunities and scope also in the field of permafrost research. So hopefully in the process, we'll be exposed to or will some of the important issues related to research in permafrost will be put forth, and the younger generation will be able to use it and to come up in their life, in their career, and even they can build up the career in the field of permafrost research. So without taking much time, because I don't have any authority on it, although I know that the people, they have been visiting Antarctica or say Norway and the Northern Pole for various studies. We have permanent station at Antarctica, and through DST, Department of Science and Technology, various teams, they are visiting in the North Pole as well as the South Pole for various studies. So with these few words, again, I welcome you all for this program, and hopefully it will be a learning session for me also along with the team. But through this program, through this international webinar, I would like to welcome you all physically also to Shillong, and to see, to learn, to understand the intricacies or complexities of geological science in this region. We have very good resources, moraines, and all. Probably something good through your research. It may come to the knowledge of the country. So with this, I would like to thank once again all the experts, eminent people, to have taken out time for this program and to be sharing their opinion, and so that we are able to build up a very strong network and take it forward further. Although here I should not miss special words for Dr. Neil Ratan, because it was actually being president of PYRN. It was his initiative who has mobilized us, and probably the fruits we all are going to share, or we all are going to enjoy. So with this word, thank you very much. Thank you everyone for joining, and let's see how we'll benefit the resources being provided by our experts. Thank you. Thank you, Dr. Meghali. Please.
Thank you, sir, for your encouraging and inspirational words. Now I take this opportunity to introduce our next speaker, Dr. Adam Karkout. Dr. Adam Karkout presently is the Vice President of Permafrost Young Researchers Network Executive Committee and currently working in the permafrost zones of Hudson Bay lowlands and studying the evolution of permafrost landscapes and the associated relationships to permafrost carbon biogeochemistry and microbial ecology. I welcome you, Dr. Adam Karkout, and kindly enlighten our participants about Permafrost Young Researchers Network. Over to you, Dr. Adam Karkout. Please,
You need to unmute.
please you unmute yourself.
Adam, you are unmuted, but your voice is not coming through for some reason. Probably something to do with mic settings or something.
Mike, you need to remove and now. Megali, we can go on to the next speaker in the meantime. Shikhar, please help him setting his voice.
Okay, sure, sir.
Sure.
Okay, so now moving ahead, now I take this opportunity to introduce our keynote speaker, Dr. Rasik Rabindra, former Director, National Center for Polar and Ocean Research, Goa, India. Dr. Rasik Rabindra served in various positions in Geological Survey of India for 34 years between December 1971 to January 2006. He is a veteran Antarctican and participated in Indian expedition to Antarctica in 1987 to 1988 for the first time and subsequently led 9th Antarctic expedition in 1989 to 1991. He was chairman of the DST constituted Program Monitoring Committee on Dynamics of Himalayan Glaciers from 2007 to 2012 and was appointed Chair Panikkar Professor in October 2012 by Ministry of Earth Sciences. He has been elected to the UN Commission on Limits of Continental Shelf for 2014 to 2017 term. He has been recipient of the National Mineral Award in 1990 for contributions to national Antarctic expeditions. He has received Antarctic Award in the year 2002 from Government of India, H.N. Siddiqui Gold Medal from IGU in the year 2011, Professor Prem Bahadur Verma Memorial Lecture and Rajiv Gandhi Excellence Award in the year 2011, and National Award for Polar Sciences and Cryosphere in the year 2013. And now I invite Dr. Rasik Rabindra to deliver the keynote address. Over to you, sir.
Unmute,
Sir,
please.
please kindly unmute yourself.
Thank you, Megali, for your kind words. It was a really nice gesture on your part. And I must thank Dr. Walia for inviting me to this prestigious webinar. I think it is going to be for the first time that the participants will listen to the permafrost. As rightly said, we have been active in glaciological work in cryosphere, but very little is known about permafrost. So I think this is a right opportunity for everybody in India, as also our foreign participants, to know what India has been doing in all the three poles. I say three poles because Arctic, Antarctic, and the Himalaya we consider as the third pole. So most of us have been engaged in all these 3 poles. And as Dr. Walia rightly introduced, there have been nearly 40 expeditions that have gone from National Center for Polar and Ocean Research, which is a autonomous body of Ministry of Earth Sciences, to Antarctica. And we have a research station in Arctic, which has been there right from 2008 onwards. And every year our participants, they go to both these poles, and all of you know about our active work in Himalayas. So permit me to share my presentation.
Yes, sir, you can share, sir.
But I don't see my presentation. Just a minute. Was on, but I think it has. Yeah. Is it okay?
Yes, sir. Yes, sir. You can proceed.
Okay. What you see here on my screen is a field of Canadian Arctic, and Adam Karkout will recognize this, which is from his own area of Canada. And the permafrost is a very well-known feature in most of these areas, like in Canada and in some other areas of the Arctic terrain. I have divided my talk today into several points, and I'll just tell you, I'll be dealing initially with the definition of permafrost. Actually, I wanted Dr. Adam Karkout to speak on these issues because he is a young worker who has been working on this. So, but since his talk is going to be after my talk, so I take this opportunity to introduce the word permafrost, how it has been originated, what is the genesis of this word, and then the spread, how far permafrost is spread in the different continents of our Earth, and what are the impacts of rising temperature on permafrost, as also on the total climate of the world. As most of you know, that permafrost is a very, very sensitive thermometer which records every single movement, every single change of the climate change. So this achieves a lot of significance. We will deal with the active layer of the permafrost. It is one of the part of the permafrost structure. And then we will also discuss some research avenues, identifying some of the top research questions that have been identified for permafrost research, both in India and in abroad. Coming specifically to Himalayan context, we will identify or try to identify some of the permafrost landforms. We will also see what is the mapping status of the permafrost in the Hindu Kush Himalayas, and what is the impact of rising temperature on permafrost on wide variety of parameters, and then impact on the environmental and the ecosystem of our planet. And this permafrost change also has got a societal impacts, the impact on the communities, their health, their structure, their livelihood. We will also try to see something about these features. Now, coming to the definition of permafrost, as you can see from this slide, it's a type of a ground right from the soil to sediment rock or sediments that has been frozen continuously for a minimum of 2 years. Now, this period of 2 years is very important. Any ground which is frozen for this amount of time, this amount of period, is defined as a permafrost. And the permafrost can extend down beneath the Earth's surface from a few feet to more than a mile at some places. And it covers huge areas such as Arctic tundra, highlands of Tibet plateau, or some isolated spots on the mountain tops of Himalaya or Alpine. So they are also classified as the permafrost, mountain permafrost. On the basis of the temperature, is very important criteria for defining the permafrost. Whereas all potentially frozen ground is a permafrost region, but not all permafrost is perennially frozen, because the ground, although of a temperature below 0 degrees Celsius, may not contain ice for all the time. So only that portion of the ground or the sediments which contain ice, frozen ice, below the ground level for at least 2 years of period is defined as permafrost. See, interestingly, you will see that some of the indigenous tribe, which is found in the Canadian Arctic, and they are called as Inuit. And if you can see from this slide, all of this ground is totally permafrosted, and in the permafrost ground, it is very difficult to dig for graves. So these inhabitants or the native citizens of this part of the Canadian territory have to put up the graves above the ground rather going down the ground. So it's a very peculiar situation which is given rise because of the permafrost or the frozen ground, where digging is practically impossible. Now, how does the permafrost form? When water that is trapped, in sediment, soil, or in the cracks from the right from the upper soil surface of the soil through crevices and pores, it goes down, and then when temperature reaches below 0 degrees Celsius, it freezes. And when the earth remains frozen for at least 2 consecutive years, as I have told you earlier, this is called as permafrost, and permafrost depths in such terrain. Now, if the ground freezes and thaws every year, it is considered as seasonally frozen. If it is not permanently frozen, it is called as seasonally frozen, and it will not qualify under the term of permafrost. Sometimes what happens is that there are deep cracks within the areas below the soil, and a lot of water will seep through, and finding a necessary space, it will form wedges. Now, these ice wedges sometimes go very deep, and as you can see in this slide, this permanent this place here, this ice wedge is very old, and as it is said here, it is a 4-meter wide ice wedge at the top of a post-glacial lake site, which overlies the glacially deformed Pleistocene sediments more than 40,000 years old. So these are some of the structures that you will find in a permafrost terrain, whether it is a wedge or it is a permafrost layer itself. Now, distribution of permafrost landform within our Mother Earth, you see, the main area remains the northern hemisphere. And if you see in this slide, there are different color bands are shown here. Now, the deep black color, which is just encircling the Arctic Sea. Now, this is the area where permanent frozen ground is present, and this is called a permanent frozen permafrost is available in all this area. Now, this contains part of the Russian Arctic, Siberia, part of the Norwegian areas, and then Canadian areas, Alaska, Greenland over here, and some portions of the Iceland and Faroes Island, and also the Norway, like Nielsen and other areas. That also reminds me that I must inform you that India has a station in the Nielsen at 80 degrees north in the Arctic, and we have a permanent station called as Himadri. Now, giving you a distribution of the Arctic, I can tell you that about a quarter of the entire northern hemisphere is under permafrost, where the ground is frozen year-round, and it covers nearly 9 million square miles area. I have not converted it into kilometers. It is 9 million square miles, nearly the size of United States, China, and Canada put together. About 85% of the land sits on the top of a layer of permafrost in the regions of Siberia, Canada, Greenland, and Alaska. And so you can imagine that what a huge portion of the land is occupied by this permafrost. Coming to our own areas in the Himalayas, in the Tibet Plateau, Hindu Kush Himalayas, these are some of the areas where permafrost is present, especially in the Tibetan Plateau, in Ladakh areas, and some higher reaches of Hindu Kush Himalaya, which are above 4,500 meters altitude. Now, floor of the Arctic Ocean is also has some permafrost. Antarctica, surprisingly, because 98% of the continent is covered by the ice, and ice can be as deep as 4 kilometers. I'm saying it 4 kilometers, that is 4,000 meters thick. So it is very difficult to locate permafrost. But in the 2% of the area which is not occupied by the snow or the ice, you do get some permafrost areas, and which are especially present in the oases or the ice-free areas of Antarctica, and Shirmakar oasis, where the Indian station is present. That is one of such area where we have permafrost, and studies have been done on permafrost. Himalayas, a recent study has indicated a significant permafrost occurrence in the cold, arid areas of Upper Indus Basin, covering Ladakh. And this study is credited to a GNU research scholar, Wani. The paper has been recently published in 2021. Large-scale assessment of the Hindu Kush Himalaya. I must explain that Hindu Kush Himalaya, when we say, we extend it to a belt of 2,500 kilometers, starting from Afghanistan, passing through western, central, and eastern Himalayas, then going through the Nepal and Bhutan Himalayas, and part of the Tibetan Plateau, and then finding or ending near the Arunachal Pradesh and areas. So large-scale assessment in the Hindu Kush Himalaya region suggests that permafrost may be covering nearly 1 million square kilometer area, which is roughly 14 times the area that is covered by the glaciers. So glaciers, in fact, we know that there are about 9,000 glaciers in the Indian part of the Himalaya, and you can well imagine how much area must be occupied by those glaciers. But permafrost has 14 times greater area than those glaciers. In the map of the Himalaya that you see under my slide, the southern part of the slide, this color index, which is a deep blue, is the area which is permanently covered by permafrost. And as you move from deep blue to purple to orange and to yellow, the degree of permafrost decreases. Finally, you come to the green area, which is only, or blue area, which is only glaciers. So you will appreciate that the permafrost is basically confined to the higher reaches of Himalayas, basically in the plateau regions, whether it is in Tibetan Plateau or some portion of the Ladakh. There is very few literature, published studies are very few on the Hindu Kush Himalayas, excepting the Tibetan Plateau, where a lot of construction activities has been taken by the Chinese in connection with the highways or the railway. So we have some good reports about the permafrost in that area. Dynamics of permafrost in the Himalayas and its relationship to the hydrology, hazards, ecosystem, and livelihood through systematic collection of permafrost and temperature data by field or remote sensing is of prime importance. And very recently, some beginning has been done, but prior to 2016, very little work was done on the permafrost. Now, I have a quote here which says that climate change affects permafrost in the Himalayas. We have to study the impact of permafrost thaw on the water, the associated hazards, and the ways in which mountain people are impacted by this. And this is said by the permafrost expert from ICI MOD, which is an organization working on the Himalayas located in Nepal. It is an integrated studies on the mountains development in Nepal. It's an international studies. The first ever research, on permafrost in the Indian Himalayas region was taken up by a consortium. It was called as Indo-Swiss Indian Himalaya Climate Adaptation Program, IHCAP, in 2016. And in this phase of the study, the team has successfully mapped permafrost distribution in some parts of the Himachal Pradesh, basically in Kullu, and it commonly occurs at an elevation of around 4,500 meters and above. Close to the heels of this study, the Indian Permafrost Network, which is part of the major PYRN, the Permafrost Young Researchers Network, it was created to promote permafrost research in our country, in India, and the National Institute of Hydrology, which is located in Roorkee. This has started collaborating with ICI MOD to exchange technical know-how and expertise in the permafrost studies in the Himalayas. A beginning was made, and this would have gone much ahead, but unfortunately, the main person, Dr. Reno Thean, who was a glaciologist working at NIH and who was the key person in this Indian Permafrost Network, lost his life because of COVID, and it was a great setback to our studies of permafrost in the Himalayas. You can get the details of this work that has been done by the National Institute of Hydrology in association with the Indian other Swiss people in that site that I have given you here. The website address is given here below. Now we come to a point that why permafrost is so important as a research subject. There are certain bullet points, and we can quickly go through them. The permafrost is essential to climate change. As I said, any change in the cryosphere, it's a very delicate thermometer which can record global warming or any sort of a deviation from the normal atmospheric changes. Any change in surface temperature leads to changes in permafrost condition, such as an increase in the activity thickness or its melting itself. And if this takes place, permafrost melting takes place, or the active layer melting takes place, then what are the impacts it will create? Are the ground slope stability will decrease, that it will impact the trigger debris flow and rock falls. It will result in changes in the hydrological system, the water quality, and the entire water cycle of the starting from the hilly terrain down to the plains will get affected. Greenhouse gas emission, ecosystem changes will take place because a lot of gases are trapped in the permafrost, carbon dioxide, methane, and we will come to those details subsequently. And if these gases they are emitted, then the entire planet is going to be affected. The forceful use of specialized construction requirements will have to be done because permafrost requires cold weather engineering, and all the structures have to abide by the different technique of engineering, which is called as cold weather engineering, because normal methods of engineering, normal methods of digging for foundation will not hold good here because of the fluctuation of the active layer. The mountain communities, with respect to their health, economy, livelihood, everything will be affected, everything will be impacted, and we'll see why and how these impacts will take place. Now, is permafrost region really depleting, and why it is depleting? Now, this graph, if you see over here, it gives you an average temperature right up to 1940 and a zero change of line, anomaly line at 0 degrees, and you can see that right from 1940 onwards, the anomaly has been rising gradually, and till 2020, it has already reached the peak. Permafrost, because of this rising temperature, is rapidly shrinking. Arctic is warming twice as fast as other parts of the world, faster than it has done so in the past 3 million years. So you can see the impact. Now the CO2 concentration, which was there way back about 3 to 4 million years at 400 ppm or so, it has already reached this level currently. Now it is estimated that there is now 10% less frozen ground in the northern hemisphere if we compare it to the level of the frozen ground to 1900s or so. When surface temperature rises, the rise in the temperature below surface will also rise, and this will result in thawing of the permafrost. Every additional 100 degrees Celsius of warming, an additional 1.5 million square miles of permafrost would eventually disappear. So this is the reason that why the Intergovernmental Panel on Climate Change is very keen that the global community must restrict the global rise of temperature below 1.5 degrees Celsius if it is possible. We know it is practically not possible, and they are even talking of restricting it at 2 degrees Celsius. Even if we meet the climate targets, laid down during the 2015 Paris climate talks, the world may still lose more than 2.5 million square miles of frozen turf. So this is a great loss, and you can very well imagine what will be the impact due to this thawing of this sort of a permafrost. Couple of slides, to show you the gravity of the rising of temperature, right from initial days of our to 2020. You can see how the temperature has gone up. Now, most of this, yardstick is from the core ice core studies, but you can see that after the Little Ice Age, in around 1700 or so, the temperatures have been gradually rising to reach a very high peak. And the anomaly is already reached more than 0.6 degrees Celsius. And because of this, the average Arctic sea ice is continuously decreasing. You see from 1978, the time from which we started getting the satellite coverage, satellite data, and you can see the slide is very steep, very steep. Now, some pictures, they are very interesting. These are two pictures I got from some of the sites. The first photograph on the top, on the left-hand side, is taken in 1900s, and the second one is taken in 2000. So there's a gap of around 100 years, and you can see this is a front area of a glacier. This is a snout of a part of a land glacier, and these are small peaks that you can see from the far away. And somebody is going through this fjord. It is in the Norwegian part, but after about 100 years, you can see the whole of the mountains are visible. The glacier has practically vanished, and the ground has emerged from below the glacier. So in 100 years, what changes have taken place you can very well appreciate. As also from this slide, which shows you that this line, is the original line of 81 to 2000 line when the glaciers ice spread was there in the Arctic Ocean, and this is the current situation of 2020. See, so much of the ice, of the sea ice, has already been lost to this global rise of temperature. I am talking about the rise in temperature because this rising temperature is ultimately going to be having a cascading effect on the permafrost. Now, some example from our Adams territory of Canada. There was a devastating rise in temperature, from minus 17 degrees to 20 degrees to 19 degrees. See, and the total rise in the temperature was around 20 degrees warmer. So from minus 17 to 3 degrees Celsius, positive 3 degrees Celsius, you can see the temperature last year touched a peak of nearly 20 degrees warmer terrain. Now, if this sort of a thing happens, what will happen? What will be the net result? Huge variations are not normal or natural. This is something unnatural, abnormal. And scientists working on an island off the north coast of Canada, relatively near to the Dead Horse, have discovered evidence that warming in the Arctic is triggering thousands of landslides. It is not one or two or individual or a isolated landslide. It has initiated a cascade of the landslide in the terrain because of the permafrost loss. It's another very good comparative picture. You can see that in 1985 the spread of the Arctic sea ice, and gradually if you come to 2002, you can see and you can compare the sea ice has reduced. I have deliberately avoided showing the video, otherwise you could have appreciated how gradually ice has vanished from 1980s to currently, because sometimes the videos don't work in a webinar. And then you see what is the mechanism of the loss of the ice is sea ice is that a gyre is established in the central part of the Arctic Sea, and then when this fresh snow, it circulates like this. Then it moves gradually because of the gyre, and it comes out and moves in this direction, and from the Greenland side it comes and it vanishes in the ocean, sea. So this is the situation in 2020, when most of the ice which was here, due to the gyre or due to the movement of this in the Arctic Sea, this has come, this has flown, and this has gone out of the Arctic Sea area and permanently lost. Now let us understand some part of the permafrost. What is its constitution? The top portion of the permafrost snow is called as active layer, and you can see in this slide, this is the active layer. The top layer of the ground, subject to the annual thawing and freezing in the areas where either salinity or clay content of the permafrost always leads it to thaw and refreeze annually. It is underlain by permafrost. Now this layer, it keeps on thawing and again freezing, because of the temperature rise. And this is called active layer because this will keep on fluctuating. And because of the fluctuation in this layer, lot of landforms you can see in that area, which is, under which this permafrost lies. Thickness of the active layer, I have already told you that it varies from year to year, depending on such factors as the ambient air temperature, vegetation, drainage, soil, or rock types, and water content, of course. Degree and the orientation of slope will also be a very important part, because if the slope is there and on the mountain slope, then possibly the permafrost will be on a sloping gradient. It becomes thicker in an area where there's a land is stable or land is horizontal. We got an opportunity to work in permafrost in Antarctic, because when the Indian station Maitri was being constructed during 1987-88, and I happened to be there. So we were drilling, we were excavating the foundation. The station is in the U shape, the foundation had to be excavated in a U shape pattern to make it for the pillars. So we had number of pits, which have been numbered as 1, 2, 3, 4, 5. And since the digging was going on, I took the opportunity of collecting the samples from there, and then till we reached the permafrost here. So this is some sort of a block diagram wherein we could see that the very coarse sand and boulders and coarse sand with some of the rolled, clast were there, and then silt was also there till we reached the permafrost. And beyond this permafrost, we couldn't go because it was very thick, but by that time, we had already reached about 60 centimeters, so that was good enough for our construction of the station. Now, coming to the research questions that are very important and that have to be dealt in and that form the topic, I think our friend Adam would have highlighted these questions because he's an active researcher who is working on the permafrost. And I was going through his profile and I found out that he's working on the biogeochemistry as also on the release of the mercury from the permafrost, which is a very, very hazardous element which is coming into the atmosphere of Arctic. And most of the areas which are habited around the Arctic, you know, those people, indigenous people, they are getting affected by that. Well, very recently, there are two very important events happened. The one was the ICI mod had organized an online forum on permafrost, and it has just concluded. From 20th to 23rd September, there was a 3-day international workshop on permafrost, and the theme was Cryosphere Forum 2021, which dealt with the status of research on the changing permafrost and associated impact in the Hindu Kush Himalaya. Exactly what we are going to discuss in this particular, which is the title of this webinar. So it will be very good if we see what happened in that workshop, what was the theme of the conference, and what were the papers submitted. I have done some small summary of the proceedings of that, and I think I have the permission from the ICI mod because it was in a public forum. So I have taken liberty of putting up that work in this forum to showcase what an excellent work ICI mod has done in bringing different workers together. Basically, all the young workers from the PYRN were there, Apex was there, Association of Young Polar Workers from Antarctic were there. And secondly, there's one paper which is published in the Cryosphere on the same theme and which says brief communication, it was there. And it is the title is Future Avenues for Permafrost Science from the Perspective of Early Career Researchers. And I think this paper has got a great relevance to our young researchers who are actively working in the permafrost. I'll again go to this detail of this. I have some time, I think, to tell you what the findings of these people on the avenues of the research. Now, this is a table, actually this exercise followed a similar exercise which was done by the SCAR, Scientific Committee on Antarctic Research, and which was published in Nature. And I happen to be one of the co-authors of that study. What was done in this study was they took up the two candidates, two researchers from entire working community from Antarctic. They asked them to raise 5 questions, and then all those questions from the different delegates, they were pulled together, they were shortlisted, and finally discussed in different groups, different batches, and screened down, shortlisted to 6 priorities. And those 6 priorities were then worked out, and it was published. A similar exercise has been done here, wherein the Permafrost Young Researchers Network researchers were called, Association of Early Career Scientists, Apex people were there. 71 questions were received from 31 active workers. 88 participants were there, and then these questions were routed through these scientists, and 5 top questions were shortlisted. Dr. Devesh, I have time. Okay. So what are those 5 questions? Just excuse me. The 5 questions taken from them are, how does permafrost degradation affect the landscape dynamics at different spatial and temporal scale? What is the effect on the landscape? Second was, have the thermal models been improved? Do we have the thermal models to predict permafrost or see what is happening to these permafrost areas? How can the traditional knowledge gained by the indigenous community be used in our research in permafrost? The 4th question was, what are the future environmental changes that one can see from the permafrost distribution or their degradation? And then what is the influence on infrastructure, on the thermal regime and stability of the permafrost in different environmental settings? We will try to touch upon these minor questions as we go on, as we go and proceed in the, in our talk. Now, fundamentally, once you discuss anything about permafrost, you have to consider that you are talking of glaciers, because the cryosphere regime is also composed of glaciers, and unless you know the dynamics of the glacier, how the glaciers are retreating, what is the health of the glaciers, what are the ablation and the accumulation pattern of the glaciers, what is the snowfall, what is the precipitation in the liquid form. Possibly you cannot work on the glaciers. Given the extreme value of the Hindu Kush environment, steep mountains, vast high elevation, plateaus, extremely dry spell, cold climate, it is to be expected that the diversity of the conditions and phenomena encountered in permafrost will exceed what has been previously thought of. As I said earlier, the area occupied by the permafrost is 14 times that of the glaciers. Now, what are the landforms you can identify in a permafrost terrain, or by seeing these landforms, how can you judge? Well, there is a permafrost layer lying underneath this particular ground. And the best example is these parasites, which are seen from above, from the helicopter. These are found by the ice lenses over here, a peat plateau here, the pingos, these are again from the Canada, and these are some of the pattern grounds or the accumulation of the stones. These are some of the ice wedges. In these wedges, you will find the ice wedges and some of the ice wedges in the sediments over here. Some of the permafrost structures which are from the Shimaka oasis of Antarctica, as I told you, there is 2% area in Antarctic which is ice-free, and we could see these features in Antarctic very close to our Indian station in Antarctic, that's called Mercury. Why these structures formed? It is just like a sieve action. When you know that there is a layer which is thawing and freezing again and again, so all these small pebbles and boulders which overlie, they get sorted like a sieve, So the boulder, coarser boulders will be on one side, and the finer boulders or the shorter boulders will be in the center, and fine sand and silt will come in the center part. The fundamental study on the permafrost has to deal with the heat budget studies, and the surface energy balance is the basic parameter that we have to study. It has been observed, that the Ladakh region has a very low relative humidity, nearly 43%, resulting in the lower incoming long wave radiation and strongly negative net long wave radiation. So basically, we have to monitor, we have to record these two sorts of the radiation if we want to see and study the heat budget of that particular area, to see how much heat is being transported from the thermal regimes to the ground, to the permafrost. The land surface at these high elevation is overall colder than the location at the higher relative humidity. And further, it is found that the high incoming short wave radiation during summer months in this region may be facilitating enhanced cooling of wet valley bottom. So these indications were also given by the Vani in his studies there in the Ladakh areas. In some portions of the Lahaul and Spiti valleys, where Ministry of Earth Sciences and the NCPR is maintaining a research station. It's called Himanch. It is very close to the Batal Glacier. If some of you have gone to Chandratal and others, you see a small area where a lot of instrumentation was done by NCPR, and I was there in this camp in 2013 and 14. And then we had established so many equipment, to find out what is the heat budget of that area. I will just tell you what are the equipments we had established. High volume sampler for collecting atmospheric black carbon, fine particulate matter, which is less than 2.5 micrometer. Automatic weather stations for collecting meteorological parameters like temperature, humidity, other weather parameters. A sensitive pyranometer to monitor the incoming short-wave radiation, and sun photometer for microtops. So all these equipments, they gave us several parameters on the weather, which helped us to calculate the budget. So another factor, another parameters, when plants and animals die in a cold area, so what happens? The microbes that decompose with their bodies, they release carbon dioxide, methane, and other greenhouse gases, into the air. A deep freeze preserved decomposed organisms and the gases they would otherwise emit underground. So this permafrost is storing all these greenhouse gases, the microbes and everything in its womb. And when this this entire permafrost will get thawed or defrozen, then it is bound that all these gases, all these greenhouse gases, and even the microbes, they will be released to the atmosphere, causing untold misery. So these are some of the statistics, as per the United Nations Framework Convention on the Climate Change. Methane emissions, permafrost taps considerable amount of methane, as all of you know. are responsible for around 30% of the warming since the pre-industrial era. To reduce emission of the methane, US, European Union and UK and some other nations plan to place before the Committee of Parties 26 conference, which is to be held in October this year, a global methane pledge, which will request all the countries to restrict the global methane emission by 30% below 2020 level. I don't know whether it is possible or not, but what is said below is more causing concern. You know, the world would require to cut the greenhouse gases emission by 25 to 45% from 2010 level by 2030 to meet the Paris Agreement goals of limiting warming by 2 degrees Celsius or by 1.5 degrees Celsius. The current pledge by nations would decrease the emission only by about 12%. So it is very difficult to imagine that we can still reach that 40% goal, which seems practically impossible. Now, what is the impact on the environment? You see, most of the roads will get deformed, or air, as you can see of air like this. Carbon and methane will be released to the atmosphere. The potent neurotoxin, it is estimated that 15 million gallons of mercury, and again I'll draw attention of Dr. Adam Karkout to this figure, which is supposed to be leaked if the permafrost gets totally unfrozen. Thousands of microbes from soil, some diseases carriers may be released along with the gases. Communities will be deeply affected. You know, this is a picture from the Arctic, Nielsen area, Svalbard, Spitsbergen, where most of these animals, you know, they feed only during the summertime when there's some sort of a greenery or some vegetation is there, as you can see in both these areas. And moment this area gets, the winter comes, this entire vegetation will go away. The entire ground will be totally frozen. So this is the only time when the active layer gets, thawed, that some vegetation will come. And in case these small areas of permafrost, they are totally abolished, they vanish, then all the communities, their houses, their wild animals, everything will be deeply impacted. We must also know that 35 million people live in a permafrost zone in towns and cities built on top of what was once considered permanently frozen ground, but no longer it is a permanently frozen ground now. In areas located at higher altitudes of the Hindu Kush Himalaya, the ground often consists of permafrost. The temperatures are slightly less cold in summer, and perhaps because of the lower altitude or a greater distance from the pole, the surface of the permafrost melts most of the year, and this causes a lot of landslides. As you must have seen in the last couple of years, the degree and the number and the frequency of the landslide which the Himalayan areas have encountered, whether it is a Rishi Ganga project or Kedarnath, it is a tremendous increase in the frequency of release. This I have already told you that we are working on the glaciers, and once Ministry of Earth Sciences and the National Center for Antarctic and Ocean Research has initiated a huge program on integrated studies of the selected glaciers, also on the permafrost, to collect essential parameters on glacier dynamics, weather parameters, radiation, balance aerosols, carbon relationship with the discharge runoff, and also on the hydrological aspects of different areas. There is a lack of data available, but there is a need to study all these areas, and we can really appreciate that going to the height of around 20,000 feet in the Himalayas is very difficult. It is easy to go in the Arctic areas where you see the permafrost at the sea level, but once you come to the Himalayas or Hindu Kush Himalayas, you have to rise up to 5,000 meters height to reach glaciers or to reach the permafrost region. And so the remote sensing is the only possible tool where you can collect the data and then possibly field check it by the field checks. So these are some of the glaciers, where people keep on working throughout the time of the ablation season, which is from April, May to September before the other periods. Hydrological aspects are very important because a lot of water, it seeps through the areas like Moulin and others, and from the discharge of the glaciers, and ultimately it contributes to the soil moisture, and which leads to the permafrost. I will quickly go through the Permafrost Workshop of ICI MOD, and you see these are the heading of the sessions that were there: climate change and permafrost impact, ecosystem and permafrost, hydrological regime and permafrost, remote sensing, rock glaciers and hazards, field investigation of permafrost. So practically all the aspects, and a brief summary of this session is given. And since this is being recorded, so the participants or the researchers can always download it either from the site of the ICI mod or from this presentation. Now, I also tried to draw a summary of the presentation which was made in this workshop. And you can see that maximum of the papers, they are on the machine learning tools of the permafrost or modeling. What can the modeling exercises or the machine learning tools help us in identifying the permafrost distribution and permafrost in the Himalayas, whether it is a carbon export or it is a hypothetical estimation or it is a field measurement of major permafrost or rock glaciers. Geophysical tools have also been used to work out the potential methods to monitor the permafrost, and geomorphic landforms and also studies have also been done. The effect of climate, the different weather patterns, whether it is westerlies or it is normal temperature, normal rise of the atmospheric interruptions in the Himalayas, they have also been studied. And all these features have been put together. So I'll still request all the young workers to go to these two sites, the paper of this gentleman which I have projected here, or to the ICI mod workshop, and try to see what are the different research themes that they can work on. Now this last slide, it shows a picture which is very well shown in the website of a polar bear which is being deprived of its habitat. Now, if the global temperature rises, the Arctic sea ice vanishes, this poor fellow has no place to go. So it is very essential that understanding and appreciating the implication of the climate change to save our Earth for future generation is well taken care of. Thank you, gentlemen. Thank you for your patience.
Thank you, sir. It was very informative and very elaborate lecture. Thank you very much.
Thank you, sir, for very informative and excellent presentation. You have well highlighted why permafrost is important as a research subject, and we are really grateful to you for the time and effort you took to share your thoughts with us. Now, I would like to request Dr. Adam Karkout kindly enlighten our participants about Permafrost Young Researchers Network. Over to you, Dr. Adam Karkout.
Thank you, and I hope everyone can hear me now.
Oh, yes, you are very much audible.
Perfect. Sorry about that issue earlier. It's still quite early in the morning, and I guess my laptop wasn't awake yet. All right, I will share my screen and talk a little bit about PERN, or the Permafrost Young Researchers Network. So as introduced, my name is Adam Karkout, and I'm actually not a doctor yet. I'm about halfway through my PhD in Canada. And as discussed, I'm working in the subarctic lowlands around Hudson Bay in Canada, looking at things like Mercury and also landslides in permafrost regions. So a little bit about PERN, for which I am the vice president. Of course, PERN stands for the Permafrost Young Researchers Network, and now I think we're about 1,500 members spread across the globe. So this is who we are. We have an executive committee of nearly about 10 people, and we're spread out all across the globe. So like I said, I'm in Canada. The president, Niek Speetjens, is in Amsterdam. We have quite a few on the executive committee who are from Europe, some from Asia, and a few others from Canada. And so you can see in this map, it's the members that we have spread across the globe. So PERN has a pretty wide reach, with most of our members coming from the United States, Canada, Russia, quite a few in Greenland, and quite a few in India too. So this is really helpful for young researchers, because not only are we developing our own skills as permafrost researchers, but PERN helps to facilitate making connections with other permafrost scientists across the globe. So this is the current executive committee for PERN. We started our term in the fall of 2020, and we'll be finishing our term in summer of 2022. So we have about just under a year left, but it's been quite a busy year and a half, and we've had a lot of fun with PERN. But of course, because of COVID, things have been a little bit different, but we'll talk about that in a few minutes. So PERN also has national representatives from all of the different countries. So I believe that Neil Ratan is the national representative for India, but basically the national representative can come to the PERN Executive Committee and the PERN Council, and there's funding available from PERN for organizing events such as has been organized today. So there's lots of different opportunities with PERN, and we're always happy to promote permafrost science. So we've had quite a few events in the last few years, and this is not a complete list, but we have quite a few things going on. And one of the things that's happening right now is the Permafrost Science and Engineering short course, and I'll talk about that a little bit more in the next slide. But we are also usually very involved with conferences that have a permafrost aspect as part of the conference. And so the next one coming up is the Regional Conference on Permafrost, and that is taking place in Alaska. Of course, it's an online venue now. It was supposed to take place in Boulder, Colorado in the United States, but because of COVID, we weren't able to do it in person. So what PERN is doing is planning a day for students who are PERN members, and we give an introduction to PERN, and we're also planning to have different workshops, so just to help students build and develop on their skills. So this year we'll be doing one on science communication and how to visualize your science and how to be an effective communicator, and also have one on writing grants, so students who might first be starting graduate studies can learn how to write applications for different funding opportunities. One thing that I really liked that we did this winter was the PERN Christmas. And so one of our executive committee members, her name is Lara, and she's from California. She organized the PERN Virtual Secret online gift exchange. So basically what we did is a bunch of our different members put in their names, and then we distributed names to other people who had joined, and then we were able to just send each other virtual gifts, being a card or a song or something something creative, just to connect people across the world in a time where we all feel a little bit disconnected. We also have many ArcticNet social conferences. So this is a conference that occurs in Canada every year, and before in person, PERN would always plan to have like an in-person social evening. But of course, this is something that the national representatives can do as well, and they can apply for funding to host things like these social events. And then there's been quite a few other events who've been organized by national representatives or regional groups. I won't go through all of them because some of them are from before the term that I was vice president, but there's usually a lot going on in the Permafrost Young Researchers Network. So this is one of the events that I told you that's going on right now. It's the Introduction to Permafrost Science and Cold Regions Engineering short course that we've arranged and are currently running. So the idea behind this was that permafrost science and cold regions engineering are generally very closely related, but the two disciplines are quite different, and the background and the knowledge required to understand are quite different. So what we at PERN wanted to do leading up to the regional conference on permafrost, because it's also coupled with a conference on cold regions engineering, we wanted to give a course where people could learn about each other's backgrounds. So we have 2 lectures on permafrost science, and we're going to have 2 lectures on cold regions engineering. So we're currently about to start week 3 on the 2nd lecture of permafrost science. And then we'll be having the 4th week, which is our 2nd lecture on cold regions engineering. And at the end of the conference, we're going to have a panel discussion with all of the 4 speakers. So that way we can talk about some of the gaps in knowledge or gaps in communication between permafrost scientists and between cold regions engineers. so that we can really understand how to work together properly. So this is one of the exciting things that we're working on right now. And if you are interested, we are still accepting registration, so you can come for the 3rd and the 4th week, or we do, much like you're doing today, record the sessions and then we put them up onto our YouTube channel, so you can go and watch them after the fact. So this has been something that's been really great, and I've been really excited about how it's going. And this is also something that PERN had partnered with other organizations for. So PERN is always looking for partnerships and ways to promote permafrost science. So for this course, we partnered with the Canadian Permafrost Association, the United States Permafrost Association, and the International Permafrost Association. So this is another thing that we like to do at PERN, is when there is in-person conferences, we usually organize for awards and for travel grants. So PERN is funded by the International Permafrost Association, so we get funding from them allocated to us each year, and we also do our own fundraising as well. So with these funds, we organize things like travel grants for conferences. So if someone or if PERN is going to have a presence at a conference, sometimes like the American Geophysical Union or different conferences on permafrost, then students or PERN members can apply to receive this travel grant, and we can help to offset some of the costs for traveling to conferences. Of course, this hasn't been possible in the last 2 years because everything has been moved to virtual, but we are still planning for awards to be at our next virtual conference, at the Regional Conference on Permafrost in the United States. So what we do with awards is we usually like to host best presentation and best poster awards. So PERN will organize for students to submit their name saying, I'd like to compete in the best presentation award. And then PERN will organize different judges, will go view all of the presentations. And then at the end, we'll provide an award to those who had the best poster presentation or the best oral presentation. So PERN is also very heavily involved with science communication. You might see us on Twitter or on Instagram or Facebook. And more recently, we've developed a LinkedIn profile as well. So Twitter has actually become probably our main platform for science communication. Our followers have gone up quite significantly, and I think we're actually more than 875 now. But what the previous executive committee had done was posting permafrost paper a day. So they would post some of the new permafrost papers coming out, and members could read them and vote on which ones they liked best. We have about 1,500 registered members on our website. And so like I showed earlier in the presentation, these members are from all across the world. The previous XCOM posted over 700 permafrost papers a day. And what the current XCOM is doing that I'm part of is we're doing the permafrost alphabet. So we're going through the alphabet from A to Z, and we're basically just picking different permafrost terms. So for example, our first one was A, and we made posts about the active layer, showed pictures of the active layer, what the active layer is and why it's important. And we're continuing to do that as we work throughout our term. We also have lots of videos up on YouTube from some of the seminars that we've done. We continually send out newsletters. So if you're a PERN member, you would have received these newsletters. They basically outline what the executive committee is up to lately, what different opportunities are available in PERN. And we also advertise different PhD positions, master's positions, postdoc positions, so that way we can share with our members what different opportunities are available in permafrost. And we've also had many online seminars during COVID. So we've invited members to present on their research, and then we can have discussion later on. So we've done quite a few other things too. I won't spend too much time on this because I don't want to go over my time. But you may have heard about the Frozen Ground cartoons. So the previous XCOM had translated that into Russian, and it's available in many other languages as well. And we did a PERN census so we can figure out who our PERN members are. And I'll present a little bit about this, and then I will give up the floor to the next speaker. So, of course, during COVID, things had to change. So the International Conference on Permafrost that was supposed to be in Lanzhou, China, unfortunately was canceled and now has been rescheduled to ICOP 2024 in Whitehorse in Canada. But PERN was planning to have presence at this conference, and same thing I discussed earlier, plan a workshop in icebreaker, social event, and travel grants, but now we'll be saving that for the 2024 conference. And of course, we've done quite a few Zoom seminars, and we have been very active on Twitter. So getting into the PERN census a little bit, we went through and surveyed all of the members that are part of PERN. So it's a pretty even mix of male and female, and most of the Permafrost Young Researchers members are between the ages of about 19 and 40. So this is where our members are, kind of similar to the map that I had showed earlier. It's quite concentrated in North America. There's still quite a few members in India, which is really great, and quite a few members in Europe as well. So this is typically this is what it looks like for who our students or who our members currently are. So you can see that it's mostly postdocs and PhD students, but we still have a really great number of undergraduate students, master students, and quite a few other people as well, which is really awesome. So PERN is really open to anybody who's currently in graduate school or undergraduate school, is a postdoc, or has been out of their PhD for, I think it's 6 years is our cutoff. So that's my quick introduction to PERN, or the Permafrost Young Researchers Network. Like I said, you can visit us on our website at pern.arcticportal.org. Here you can find a lot of different great resources that we have online, or you can use it to keep in touch with us. Or if you're not a member, you can go to this website and you can sign up to be a member, and then you receive things like our newsletter. And of course, you can feel free to follow us on any of the social media accounts. We have Facebook, Twitter, and Instagram, and we're fairly active on most of them. And this is a really great way to keep in touch with all of our members. And we share members' posts so everyone can see what we're all up to. So that's my quick introduction to PERN. And I thank you very much for listening and for inviting me to talk about the Permafrost Young Researchers Network.
Thank you, Mr. Adam Karkout, for broadening our perspective with your informative address. And really, we are very grateful to you for the time and effort you took to share your thoughts with us. So now, moving ahead, now I take this opportunity to introduce our next speaker, Professor Arundeep Ahluwalia, former head Center of Advanced Study in Geology, Punjab University, Chandigarh, and currently member of Intersectoral Advisory and Monitoring Committee of National Program on Carbon Sequestration Research. Professor Eddie Ahluwalia commenced his career in the year 1972 in Geological Survey of India and served the organization till 1982 in different capacities and assignments, especially in Andhra Pradesh, Himachal Pradesh, and Lucknow. And he has joined Punjab University in the year 1982. He has also been a guest speaker in various countries like Canberra, Australia, Sweden, Oxford University in UK, and universities at Cincinnati, Penn State, Dayton, Nevada State, USA. He has also been a guest researcher in various countries, and he recently spoke in 14th Sorry. World Congress on Environment Management, organized by IOD and ET now. And during his last years of his career, he has published several papers in reputed journals like Nature Geological Magazine, Chemical Geology, Mineralium Depositor, etc. Sir, I would like to request you for delivering the lecture on Himalayan eco and geotourism across borders, a panacea for affluence and peace in South Asia. Over to you, sir.
Yeah, and above all, whatever you said, Meghali, he is excellent human being and very humble, and he has accepted our invitation to be there with us.
Yes,
Yes, please, sir.
Meghali, you're factually incorrect. In fact, I'm not a member of that committee any longer. It was 5 years back. Oh, that was an old CV which I sent. I told Neelatan that today I'm a mass communicator in earth sciences and environmental sciences. And my duties are purely volunteer duties. And I was involved in that UN project called International Year of Planet Earth. That was the triennium from 2007 to 9 when I was at University of Cincinnati as a visiting professor. So that project is over, but my spirit of involvement in that project is what carries me through. And this, what I'm talking today is not actually, it's called a special lecture, but all my lectures, to be effective, are not lectures, but chit-chats. If you don't indulge in a informal, easy, multilingual interaction, especially in a vast country like India, with so many languages and dialects, you don't succeed. This being an international meet where we have friends from abroad, I'm not speaking in Hindi. Otherwise, I'm a compulsive multilingual speaker. Thoda sa, Devesh, I would, my guest from abroad would excuse me, just 2 sentences in Hindi. This is a Hindi fortnight. Hindi is the largest spoken language in our country. And this is a fortnight, Hindi Pakhwada. And what I'm saying, this Himalayan eco and geotourism across borders looks crazy to people, seeing the reality of the hostilities at the borders. But what may be the reality today may not be the reality tomorrow. It should not curb your free thinking. It should not curb thinking of a futuristic world where people will just boot out these warmongers. And you may, in fact, I'm inspired by one thing that we have across North America, across Europe, we have open borders. Researchers can walk in from one country to another. And I have worked in the Northwest India as a geologist to Geological Survey of India. I started working in 1977 in Lahore Spiti, and we had worked in most of the highest passes. Rotang was the entry point, Kunzam Pass, Shinkun La, and Takling La, and Parang La, 18,500 feet pass. And even after, because once a GSI type geologist, I got the typical GSI ambience in my inside me, and my university friends till my retirement, though I was originally from this university, kept on calling me GSI wala, and they used to wonder how can a university professor be going frequently to high altitudes. And in my last 3 months before I retired, we had gone on a Indo-US expedition to Spiti Valley for Permatriassic drilling and sampling across the border of PT boundary. But before that, I had been working in the Soker Lake for the climate change program with friends from Nainital and Free University, Berlin. Unfortunately, due to some reasons, I don't have any publications on that, but one primetime German movie had that they actually budgeted the visit to Soker Lake and the drilling on a floating platform. Listening to all this talk about from the great hero of Antarctica, Rasic, and a young friend from Argentina, I wonder if parts of Soker were, though it won't come in sensu stricto in the permafrost category, if I went to Soker Lake bed a bit early, May end or June, I could drive on it easily, I could walk on it easily, but a month or two later, there were instances where vehicles would sink into that, and it would be extremely risky. I was told Watt Institute nearly lost a vehicle into that swampy area. So what was possibly hard due to its being frozen was not hard a little later. So coming back to my thesis about shared Himalayan eco and geotourism across borders, I feel we are not able to do it. We have not been able to do it. We are not doing it because of poor focus on geosciences and rather very unstable focus on environmental sciences. Courts have intervened and we have introduced a compulsory environment education, but anything compulsory is not from heart. There's been a poor focus on geosciences and environmental sciences in South Asia. I'm not singling out India. It's South Asia. This is the South Asian trait. And China is almost like a Western country in matters of earth sciences and environmental sciences. And I'm asking for this sort of collaboration, this sort of openness, because any country which has a poor focus on earth sciences and environmental sciences is doomed to remain downtrodden and poor. All of our poverty is going to stay forever if we don't, as a nation and as a subcontinent, wake up to the need of mass communication, mass awareness, because this program of IYP listed out that we need 100 times or much more than the geologists and environmentalists we have in the world. And certainly you cannot create that number. The degree holders cannot be created that fast. But awakened public, what it called, the word they used was citizen scientists, can be created quite quickly. And becoming a citizen scientist doesn't require a degree. Again, I would revert to Hindi. ज्ञान किसी कागज के टुकड़े का मोहताज नहीं होता. That degree is a scrap of paper, but knowledge is there in your heart, and you feel like a geologist, you feel like an environmentalist. And I'm proud to say I have a grandson who is yet to be 6 years old, who recently learned speaking. He was late in picking up speech, but he says, I'm a geologist. One day he would say, I'm a hydrologist. Another day he would say, I'm a paleontologist. He remembers names of almost all dinosaurs, as many as my great friends, Dr. Ashok Sahani or Dr. Ashok Khosla. I know, and I wonder how knowledge can come with curiosity. So coming back to the theme, I said affluence and peace. In fact, on 14th March 2019, during that time when India had struck Balakot, etc. And there was a grenade explosion in Jammu bus stand. I was invited by the cluster university, Jammu, for a talk on geosciences. They were having a basic sciences workshop. And fortunately, that university, though headed by a physicist, chose to have a speaker on earth and environmental sciences. We are considered those gray-collared scientists, and I'm sorry to say, our friends who are the white-collared scientists, the physicists, the mathematicians, the biologists, biotechnologists, etc., often confused between geology and zoology in our country. It's a shame, but that's the reality. We've got to get out of that ignorance and deep slumber about the need to awaken the entire country. I'm doing my bit. I'm going to be 72 in November, but hopefully 10 or 15 years or whatever I live, I will dedicate my 100% time. I'm a whole-time science popularizer. So that's my introduction. Whatever was my past is past. And this is the program, Geoscience for Society, which is in my heart. I'm totally dedicated to, I'm crazily dedicated to this program, taking earth sciences to society. That's the program I still work on, and it has stopped. It hardly touched the grassroots in our country. In many countries, it didn't prove to disseminate to the grassroots, but a beginning was made. And it was a great thing that over 155 countries of the world resorted to a 3-year-long public awakening, and all research programs on the earth, deep ocean, atmosphere, climate change, etc., etc. So these two programs, which were having origin in the United Nations, but spread across the planet, are my inspirations. And the political boundaries are flimsy, they are fictitious, they are man-made. This is the Mother Nature. This is the Mother Nature God gave us. And this is our landscape. This is our holy book. We often say a Shanti part, a peace prayer in India. On all sacred occasions, we say a peace prayer. That peace prayer prays for peace on the planet. It prays for peace on all extraterrestrial planets. It prays for peace on waters. It prays for peace on the vegetation. It prays for peace everywhere, peace among the gods and whatnot. So that sounded a hollow ritual to me when I was a kid. But during all my mass communication interactions, the outreach interactions, that prayer is cited, and my audiences realize that this is ingrained in our Indian culture, and it is such prayers are ingrained in all cultural communities across the world. Nothing special that we do, but everybody across the world loves nature. But poor countries are poor because they have ruined nature. We are not living with nature. At times, most of the times, we are living against nature. So that's what I'm doing my little bit as an old man, disseminating information about Himalayas in the context of our planet Earth. The one university in Solan, in Himachal, which is dedicated to biotechnology and management, etc., etc., they called me for a Guru series lecture. Guru means the great teacher. Series lecture, asking me to talk on effect of climate on the Himalayas. And they also directed me that I will not speak any Hindi and only do English lecture, because that's an English speaking medium university. And I will come back to that lecture later. So, introduction to well-known Himalayan geological archives. We often say all these layered rocks, they are the pages of Earth's history, and we geologists are detectives of Earth history. So, exhibition of our spectacular natural heritage in the Himalayas, going from one pass to another, going from one valley to another. We have such a wide spectrum across the country. India is a massive landscape, very beautiful landscape, a grandiose landscape, where we have the complete geological spectrum, which is there in any big country, we have in our country. It's a shame that we have not 70 years gone, 75, 5th year, we are in the 75th year of our independence, and we are still confusing between geology and zoology. I would say people like us, the retired folks like Rasik Saab and me and lots of Geological Survey of India geologists and university professors, I'm sure these days it's much easier to interact. Thanks to God bless Corona, it taught us to interact without spending a penny, without any journey whatsoever. And so let's do our bit to create an awakening across the masses. And the target is what I said, a shared ecotourism, geotourism across borders. That would be anybody who, mark my words, not many dare to say what I'm saying, but everybody has this idea somewhere deeply buried in their hearts. Then why the hell we should be having no shared research, no shared exploration, no shared disaster management across the borders of this highest, the most, the newest and the most dynamic mountain chain. And we are, as a community of scientists, we have a responsibility dealing with Himalayan landscapes as a geoheritage. Now, in fact, it was a small note. I was very inspired by what was done in Cincinnati and around, and I had written less than half a page note from America, but published it in Bangalore, the Current Science, which I always call Nature of India. Nature magazine is a great magazine, but this is also a great magazine published from India. So that geoheritage is being taught. I'm very glad now every geologist, retired or working, is talking about geoheritage, is talking about your eco-heritage, but it's gradually translating into why I talk about collaboration across borders. I'm just giving an example here that we had in July end 2000, 21 years back, one midnight, we had a massive flash flood in the Himachal, from where nobody knew. All our satellites, I'm sorry to say, we are a space power, we are an IT giant, we are a nuclear power, and we are now also an economic power. But it was a shame that we didn't know from where the hell that flash flood came. And those days, these mobile phones were not there, but people communicated. Scientists did not communicate on 26 December 2004 when tsunami struck and killed 300,000 nearly people from 52 countries. But that night, midnight, 1.5 hours before the flash flood struck some places, the villagers upstream rang them on the STD and told them something unprecedented, something never seen by us is happening in Satluj. Please run away from your villages, go upslope, far off, you are going to be killed. You see, when something very strange is communicated and you're not educated about it, you're not aware about the history of such flash floods and the phenomena of flash floods, they started disbelieving that information given by friends and relations upstream. after waiting for nearly 90 minutes, they decided to come back to the village. That flash flood had taken that long time. The moment this was published in the Tribune from Chandigarh as a big news that 200 people got killed that night. 98 bridges were smashed. All powerhouses around 98 again were smashed by a flash flood. Now, had there been a collaboration between neighboring countries, that day we would have not lost a single life. So later, another lake, a landslide caused lake, started developing up the Parichu River. This is the landslide, and this is got swollen. Later, the landslide broke and it leaked. But this became an alarm. 4 years later, this is 2004, 4 years later, it continued to be an alarm. And today, some sort of dialogue had started between government of China and government of India about breaking it gently, letting the water go away so that there is no repeat of a flash flood. I'm citing this only as an example what cross-border research and geological collaboration and exchange of data and awakened public can do to ameliorate and manage the disasters. But 1 year later, 3 o'clock in the day, a flash flood came. 5 years later, it came in 2005. And 20 dead bodies from Tibet had been washed down into our area in Kinnaur. But fortunately, not a single soul in the Indian region died in that flash flood. Here is an example of a geologist. This young boy then, now he's taken retirement, he's settled in Kangra. He's popularly called Kumbi. He's a very famous photographer. He was on this side of this Leo village when the flash flood was coming. He was so conscious, he ran for his camera and he took out the camera and clicked the picture before the flash flood was about to smash this bridge, and a picture when the bridge was being smashed. And poor Kumbi was in a t-shirt. Daytime it's hot in high altitude, but later it was impossible for him to go back to his tent. All his money, rations, and tent was on the other side of the river. 18 days he was running around without any. An example I want to, in fact, I wanted to also give some examples of my outreach. I have written popular articles on geosciences and environmental sciences in almost all national dailies in Hindi and English. And I've given expert comments in almost all TV channels of English and Hindi and Punjabi and web channels also. So scientists have a duty not only to publish papers. I have 2 papers in Nature. I could have had more, but point is this: what use are your research papers if you have not paid the taxpayer? वो कर्जा जो आपने उससे लिया था, अगर आपने वो कर्ज नहीं चुकाया, that debt has to be paid to the taxpayer, that funder who gave you research grants to do research. So I wrote an article that day on this Parichu disaster. Coming back to a landslide. This is a massive landslide close to Darcha in Lahore on the Manali Leh Road. In 1919 or so, huge, this block of, these are the upper Precambrian rocks, Bathal rocks, came down on the entire village. And Meghali, you have to just tell me when I have to drop it. My talk is not a... Anytime
sorry,
you tell
sir. Sorry, sir. Sorry for interruption. You have
you
only
raise your
5
hand.
minutes to.
If you tell me to drop it right away, I'll drop it right away. But 5 minutes you're giving me?
Yes, sir. Yes, sir.
Okay,
Yes, sir.
I'll take only 4 minutes, promise.
Okay.
Not 5. So this is an example of a landslide happening and people being not aware. And today we could create through dissemination of knowledge and awareness more. And the beauty of the Spiti Valley, I would say, we often say that Himachal is the Switzerland of India. I dare say, I've been in Switzerland for 2 years. Himachal is better than Switzerland because it's much higher. Our passes are higher than the highest peaks of Europe. So please understand the value of a height, the thrill and the grandeur of the height. I'll now not speak, just run through my slides because usme main apni highest road of the world, Khardungla, and Abo, Kinnar Kailash. These are our outreach ambassadors who have been traditionally coming to our geology department, seeing our museum and carrying home the lessons of earth and environmental sciences, the thrills of seeing the fossil, the vertebrate fossil from the Shivalik hills. Just quickly, I'm running through the beauty and grandeur of the higher Himalayas where I've worked. Quickly, in 5 minutes, I think I'll run through all these slides, spending 5 seconds on each, and pictures speak better than a retired geologist does. So why should I speak when my pictures sing? Not only speak, they sing a song of geology for all of you. And all these pictures will be, I hope, shared on the YouTube, and you all will have them. And my other talks, the links to other talks, the longer talks, which I've been giving on Facebook Live, etc., I'll share with Devesh and Meghali, and those also can be shared through your forum. Quickly, I'm taking you to the beauty of the Spiti Valley, Ladakh, etc., lakes of Uttarakhand too, and Ladakh. Sokar. This is at Sokar Lake, where I was telling you about the lake becoming a swampy, dangerous place to walk on or drive. You could, this is potassium chloride. The locals knew the worth of the salt. Those who had high blood pressure, they were consuming this. This was a floating platform on which we drilled through the wet bed in this Sokar lake for work on the paleoclimates. These are the paleo lakes. This is the open. This is Spiti Valley. These are the potential airstrips for future. The urbanization. That's the Permo-Triassic section where our Indo-US expedition drilled through that paper in chemical geology and Gondwana research. These are the paleo lakes. I'm just these are the quaternaries of Kinnaur, Aglingla, and Sangla Valley. Paleoseismites, there are some closer, the paleoseismites, the evidences of earthquakes happening in the quaternary. Paleoseismites, the quaternaries. Meghali, it'll take me just a minute, another 60 seconds, and I'll be done with it.
Sir. Sure, sir, you can continue.
This is Chandra Valley, where Bada Shigri, this was in First World War, stibnite mining was done here, and the famous S.V. Srikantia was announced. His party was announced as lost. They came out 3 weeks later alive and crossed the river. That's a legend, survival and recovery of all the maps and everything by geologists. Our geologists remain unsung, untalked about, because We don't interact with governments, bureaucrats, and media, and public at large. These plant fossils were discovered by Birbal Sahni way back in 1938. He came all the way to Spiti Valley, Thabo, and this is a mix of the century. Rocks which were formed in Cambrian times were mistaken to be coincident with dinosaurian rocks. That's for 100 years. We were correlating the thalls with the Mesozoic. That can happen. Such mistakes can happen. But just running through the beauty of the microbiota of the Cambrian of Himalayas, and I think I'm very trace fossil. And to sample a trace fossil, you have to meticulously prepare a cast. And every landslide is a blessing for a geologist. A geologist is very happy at a landslide because then he gets new fossils. These are the roads of Kinnaur, tunnel-like roads. Thank you. Those are the beauties of the beautiful valley. Thanks a lot, Meghali. I'm done.
Definitely, pictures speak louder, loud and clear. So it is a nice presentation. Yeah, Meghali, please.
Okay. Thank you, sir, for very informative, excellent, and interesting presentation. And really, we are grateful to you for the time and effort you took to share your thoughts with us. So now, moving ahead, now I would like to request Dr. Aziz Ahmed, Deputy General Manager, Geology and Geotech in Intercontinental Consultants and Technocrats, New Delhi, India, an advisory committee member of Associated Chambers of Commerce and Industry of India, to deliver the lecture on tunnel deformation, its geological condition and support systems in the Himalayan region. Over to you, Dr. Aziz Ahmed.
First of all, good afternoon to all of you. Ma'am, actually today I'm not feeling well, so I'll not take much time. I'll try to finish it as early as possible. Am I audible?
Yes, you are very much audible.
Okay, so before starting my presentation, what Mr. Adam was saying regarding the coal region engineering. So my topic is basically related, very much related to that particular topic. So I'm talking about the tunnels in the Himalayan region, especially in the Permafrost region. So as we all know that regarding the Himalayas, it is very vast. I mean, everyone knows about the Himalayas. So I'll not go in details about the Himalayas. As you can see from the photographs, the Himalayan region. Now I will directly come on my my research area basically. This is basically USBRL project. You might have heard this terminology in news channels and all. That is Udhampur Srinagar Baramulla rail link project. So this is one of the costliest and prestigious project till date, and it is directly monitored by Prime Minister's office. And the temperature here in the particular, I'll talk basically about the Banihal tunnel, that is tunnel T74R, where the temperature ranges from 0.2 degree in the winter season and goes up to maximum 30 degree. So this is the scene of Banihal railway station. As you can see, this region comes in the Permafrost area. So now, as I was talking about this USBRL project, the total length of this tunnel, project was around 272 kilometers, and it started from Udhampur and ending from Baramulla. This project was started in year 2002, and the work of this intervening stretch of Katra Banihal section, that is 111 kilometers, is still in progress. and the section predominantly involves tunneling, that is around 97 kilometers out of 111 kilometer. As from this you can see the alignment, how it is going from Udhampur to Baramulla. Basically, I will talk as I told you that more than 85% area is in the tunneling zone. So I'll basically focus on this tunnel T74R regarding the alignment, geology, what is the support system, and other features. So mainly this T74 area is very complex in geological context. So basically we are the tunneling factor, the tunneling methodology rather, we are using in this particular tunnel is NATM, mainly known as New Austrian Tunneling Method. The designer is for this particular tunnel is Geodata. This is basically Italian firm, and the executing agency is Ircon International Limited, and the project is governed by Ministry of Railways, that is Indian Railways. As you can see the tunnel portals of this T74R, and what are the geological conditions we are encountering during the execution. You can see here a chimney formation inside the tunnel, and basically one terminology what sir was using earlier, freezing and thawing activity. When we are doing the tunneling in this type of region, the rock behavior is almost unpredictable, because as you know that Himalayan is always unpredictable in context of geology. So this due to this type of collapse, chimney formation and other features, the cost of the project is also gets high, and the time overrun is also one of the major factors. This is the salient features of the tunnel T74R. The total tunnel length is around 8.6 kilometer, and the finished cross-sectional area is around 38.2 square meter. There's one access tunnel in this that is known as edit. One edit is there. The length is around 585 meter approx, and the finished cross-sectional area is again the same as the main tunnel. And one escape tunnel is also running parallel to this main tunnel. This total length is around 7430 meter, that is 7.430 kilometer. And the finished cross-sectional area of this particular escape tunnel is around 18.5 square meter. And there are some cross passages, which is connecting escape tunnel to main tunnel. Almost you can say every 375 meter interval there's a scope of cross passage. You can see the tunnel T74R here. This is the main tunnel, the sky blue line, and this is the red line, and this one, the cross passage, this is the cross passage what I was talking before, and this is the edit. And this is the tunnel design of this T74R. Basically, this tunnel is designed on NATM, as I told you earlier. So the tunnel shape is almost horseshoe or modified horseshoe, depending upon the ground conditions. There's the dimension of this escape tunnel. Why this escape tunnel was there? Because as per the guideline of the Supreme Court, if we have to construct the tunnel more than 2 kilometers, then we have to give one escape tunnel for the evacuation purpose. The 3D monitoring. One of the major aspect during the NATM is the instrumentation and monitoring. Like when we are excavating the tunnel and we are providing some support, how we can know that this particular support system is enough for this particular support class? So for that, we are installing some of the instruments inside the tunnel that is known as 3D monitoring and instrumentation. So what are the instrumentation? What are the different instruments we are using inside the tunnel? That is 3D monitoring bolt. For this particular, I'm talking about this particular tunnel. That is 3D monitoring bolt, MPBX, multi-point borehole extensometer, pressure cell, strain gauge meter, and some load cells. See, this is the displacement graph. We are detecting how much after providing the support, we are checking the deformation. You can see from this graph that how much deformation is coming. And basis on this, we are checking, okay, my tunnel is safe and we don't have any collapse in future, so we can go, there's no issue. But if this graph moves more than awareness limit or alarming limit, actually this works basically on triple A pattern. One is called awareness limit, other is called alarming limit, and third is called action limit. So if my deformation is more than 50 mm, depending upon, again totally depending upon the ground conditions. So if my ground condition deformation is more than 50 mm, then we have to be very cautious that my tunnel deformation is continuously going on, and we have to provide some additional support system inside the tunnel. And this is the longitudinal displacement graph. These are the phase log. Basically, geologist's role inside the tunnel is to identify what type of rock classification is coming during the excavation, and his role is like key role, because the civil engineers, they are doing executions, but the geologist who is inside the tunnel, he is basically going inside the tunnel after the blast. He is checking the tunnel phase. What is my joint orientation? What is the type of infilling? What is the persistence? What ground condition, ground mass condition is there? Is there any ingress of water? There are several parameters through which he is calculating the RMR, basically known as rock mass rating. And on the basis of that, he is classifying the rock class. And after classification of the rock class, he is coming outside from the tunnel, and he's telling to the civil engineers, okay, my rock class is class 3, so you have to follow the design of the class 3. So immediately civil engineers are taking this support class drawing, and as per the classification, what the support system is given in class 3, they are providing it as per the support system. What are the major support system elements? One is shortcreting and other is rock bolting. These are the two major factors, support bearing element inside the tunnel. As you can see from the shortcutting, you can see this is micropotenza, and this net is known as wire mesh. And at the moment, this is not from the inside the tunnel, because on that time I was not able to take the photographs from inside the tunnel due to the light issue. This is from the portal area. And this is the rock bolting inside the tunnel. When we are after completing the shortcut, we are putting some rock bolts depending again on the rock conditions. Like it may be 3 meter, 4 meter, 6 meter, 9 meter. If my rock is very poor, then the support system will be higher. Thank you. That's it.
Thank you, Dr. Aziz Ahmed, for very informative presentation and sharing your time and experiences with us. So now I take this opportunity to introduce our next speaker, Dr. Carla Tapia Baldiz, postdoctoral researcher in geocryology area from Argentine Institute of Nivology, Glaciology and Environmental Sciences, CONICET, Argentina. She has obtained her PhD degree in Geological Sciences from National University of San Juan, Argentina in the year 2018. She has published several papers in peer-reviewed journals and conference proceedings and secured first place in San Juan Inspire Hackathon organized by the University of West Bohemia and the National University of San Juan, Argentina. She has received Young Researcher Innovation Award on Cryosphere Science and Mountain Areas in the year 2019. Now I would like to request Dr. Carla Tapia Baldiz to deliver a lecture on ground ice estimation in the Central Southern Andes. Over to you, Dr. Carla Tapia Baldiz.
Okay, good morning or afternoon, everybody. I will try to speak properly. English is not my first language, so please forgive any mistake and also forgive any external noise because there is a construction here. Let's say to here starting. It's okay. Everybody's seeing okay?
Yes.
Yes.
Slide is visible.
Perfect. So this talk is about the ground ice estimations in the central and central southern Andes of South America between 28 and 35 degrees in latitude south. It comprehends the areas of Argentina and a bit of the part of the Chile. So I'm going to repeat some definitions that were given already by Dr. Rasik Ravindra. First of all, we are going to talk about what is ground ice. Ground ice is a general term referring to all types of ice containing in freezing and frozen ground. Ground ice occurs in ice lenses, wedges, veins, sheets, pores, cavities, voids, and any other kind of opening in soils or rock. And it also, this definition includes the massive ice. At the same time, we also have or are going to work with the definition of frozen ground. Frozen ground is either soil or rock with a temperature below 0 degrees. This kind of definition includes or is based entirely on the temperature and is independent on the water and the ice content of the soil and rock. And finally, the most important definition maybe is the definition of permafrost. That is the term that identifies the frozen ground that remains at or below 0 degrees Celsius for at least 2 consecutive years. So as you may see, this definition includes both the time and the temperature in difference with frozen ground that only includes the temperature. So how do we estimate or what do we know about ground ice, especially in mountain permafrost? So first of all, permafrost is a temporary and thermal phenomenon. Thus, it is not directly recognized or is not directly visible. So its recognition is usually challenging, especially in complex terrains such as the high mountain terrains, because it depends not only in the microclimatic or the climate settings of the high mountain terrains, because it also depends on the geometry of the mountain itself, and it also depends on the kind of materials, on the kind of rock, on the kind of soils that you can find out. So the permafrost distributions that usually identified the areas in which it's feasible to expect a permanent frozen state do not provide information on the possible presence of ground ice. And one thing that we need to consider is within these permafrost areas, we could find two sets of, or two extremes of ground ice considerations. So we can find, first, ice-poor permafrost zones in which there is no excess ice that are mainly controlled by the surface energy fluxes. In these ice-poor permafrost zones with no excess ice, it is also possible to find permafrost zones with no ice at all. That is, we know them as dry permafrost areas. And also we have ice-rich permafrost zones in which the excess ice usually exists at the bases or at the base of talus, slopes, or rock glaciers. And these ice-rich permafrost zones, and this is very important, can exist or can persist even under warmer climate conditions due to the high heat capacity of the ice. And that is something it is really common here in the Andes.